Welcome back, everybody. In this video tutorial, we're going to focus on simplifying exponents. Here's a list of the basic properties that we're going to be using throughout this video. They're basically known as the Law of Exponents. Now we're given an example here. We have (6x to the power of 3 times y to the power of -4, and all this is to the power of 2 over 3x squared times y to the 5th, and all this is to the power of -3. So this is a big expression, and you're going to want to deal with it one step at a time. So looking at the numerator, notice how the whole top expression is to the power of -2. Now applying the power rule here, we can see that we can distribute -2 over each expression. So let's begin by doing that. So at the top, we have 6 to the power of -2, x to the power of 3 to the power of -2 is going to give us x to the power of -6. Then we have y to the power of -4 to the power of -2 is going to give us y to the power of 8. Now at the bottom, we have 3 to the power of -3. We have x squared to the power of -3 is going to give us x to the power of -6. We have y to the power of 5 to the power of -3 is going to give us y to the power of -15. Keep in mind, you're trying to avoid having negative exponents. So what you can do is, there's a method here. When you swap or when you switch an expression of a negative power from the denominator to the numerator, or excuse me, from the numerator to the denominator, or vice versa, the sign of the power changes. So basically, 6 to the power of -2, if you move it down to the denominator, is going to become 6 to the power of 2. And likewise for 3 to the power of -3. So let's begin by doing that. Let's swap 3 to the power of -3 and 6 to the power of -2. We're going to end up with 3 to the power of 3 in the numerator. And we can swap x to the power of -6 and x to the power of -6 as well. And that's just going to give us x to the power of 6. Now we have y to the power of 8. We don't have to touch that. So we'll just tag it along here. Over, we have 6 to the power of -2 in the numerator. Bringing it down is going to give us 6 to the power of 2. Now we had x to the power of -6 in the denominator, in the numerator, and then we're going to move it down to the denominator. That's going to give us x to the power of 6. Now we have y to the power of -15. Moving it up is going to get rid of the negative sign in the power. That's just going to be y to the power of 15. Now simplifying this even further, notice how x to the power of 6 can cancel with the x to the power of 6 in the denominator. So we can just cancel that. Simplifying 3 to the power of 3. 3 to the power of 3 is going to give us 27. Let me go ahead and tilt the camera a little bit. 3 to the power of 3 is going to give us 27. And then y to the power of 8 times y to the power of 15 is going to give us y to the power of 23. Because when you have a common base, and then when you're multiplying them, according according to the multiplication rule, they're just going to add. And then all this is over 6 to the power of 2, which is just 36. Now if we simplify, we're going to end up getting, well, we can simplify 27 over 36. And if you divide 9 in the numerator and 9 in the denominator, that's going to produce 3 over 4 times y to the power of 23. And that's our answer. Now let's look at another example. Let me go ahead and erase this. Now we're given 5x to the power of negative 4 times y to the power of 2 over 3x to the power of negative 1 times y to the power of negative 3. And the whole expression is raised to the power of negative 2. So what do you think we should do here? Well, one thing you can do is that if you swap the whole numerator and the whole denominator, this is going to get rid of the negative. This is going to get rid of the negative 2, and then that's going to change it to positive 2. So basically, if you switch them, that's going to get rid of the negative sign. So if you write 3x to the power of negative 1, y to the power of negative 3 over 5x to the power of negative 4 times y to the power of 2, the whole expression is going to be to the power of 2. Now, since the whole expression is to the power of 2, this means that the whole numerator is raised to the power of 2 and the denominator is raised to the power of 2 as well. So just to avoid confusion, we can get rid of those big parentheses and distribute the power of 2 in the numerator and the denominator. Now this looks fairly easy. Like we did before, we distribute the power of 2 to each term. This is going to give us, also notice how nothing changes within the expression. It's just the placement of the numerator and the denominator. So this is going to become 3 to the power of 2 times x to the power of negative 2 times y to the power of negative 6, all over 5 to the power of 2 times x to the power of negative 8 times y to the power of 4. Now remember what I said, you're trying to avoid negative powers. So what we can do here is change the position of the terms within the expression. But let's simplify first. We have 3 squared, which is just 9. We have x to the power of negative 2 and x to the power of negative 8 in the bottom. So we can just do this. X to the power of 8 from the denominator. We have y to the power of negative 6, so we're going to move that down there. Five to the power of 2 is just 25. X to the power of x to the power of negative 2, which was at the top, goes to the bottom, and it becomes x to the power of 2. And then y to the power of 4, we don't need to touch it. since the power is already positive. But we have y to the power of negative 6, so we can move that. Now if we simplify even further, we have 9 at the top, and we have x to the power of 8 over x to the power of 2. If we obey the quotient rule, the power of a fraction rule, yes, the power of division, I'm sorry, I got a little confused there. If you have the same common base and they're being divided by each other, you just subtract the power. So x to the power of 8 over x to the power of 2 is going to become x to the power of 6 at the top. And all this is over 25. We have we have y to the power of 4 times y to the power of 6. That's just going to give us y to the power of 10. And that's our answer. Now let's do one last example. I'm going to go ahead and erase this. This looks like a very big expression, but we're going to go ahead and try it. So at the top, we have 8x to the power of 3 times y to the power of negative 4, and all this is raised to the power of negative 2 over negative 4 times x to the power of negative 1 times y, all raised to the power of negative 3, times times 2 times x to the power of 5 times y to the power of negative 3, all raised to the power of negative 2. Now, if you recall from our previous example, if you switch the position of the expression that is raised to the negative power from the numerator to the denominator and vice versa, the sign of the power changes. So this is going to give us negative 4x to the power of negative 1 times y to the power of 3 times 2x to the power of 5 times y to the power of negative 3, all raised to the power of 2, all up in the numerator. And then in the denominator, we have 8x to the power of 3 times y to the power of negative 4 raised to the power of 2. Now let's go ahead and simplify. Distributing the powers, we have negative 4 to the power of 3 times x to the power of negative 1 to the power of negative 3 is going to give us x to the power of negative 3, and we have y to the power of 3 times 2 to the power of 2, x to the power of 10, and y to the power of negative 6. All over 8 squared times x to the power of 6 times y to the power of negative 8. I'm going to try to move the camera just a little bit. make some space here. Now let's try to clean up the numerator first. Well, a negative 4 to the power of 3 is basically negative 64. We have a negative 64 at the top. X to the power of negative 3 times x to the power of 10. Remember, if you have the same base and you're multiplying them, you just add the powers. So negative 3 plus 10 is going to give us x to the power of 7. And we have y to the power of 3 times y to the power of negative 6 is going to give us y to the power of negative 3. And we have 2 to the power of 2, which is 4. But I'm going to leave that here for a sec. Did we miss anything? We dealt with the x's, we dealt with the y, we dealt with the, yep. All over, 8 squared is just 64. We have x to the power of 6, and we have y to the power of negative 8. Now what we can do here is cancel the 64s. Don't forget the negative sign. We have a negative out here. We have x to the power of 7, and we have x to the power of 6 at the bottom. So that's just going to give us x to the power of 1 at the top, but I'm not going to write the 1 here. We have y to the power of negative 3 over y to the power of negative 8. So if we switch them, we're going to get y to the power of 8 at the top. And then we still have the 4 here. So I'm just going to leave it here in front as a coefficient. All over y to the power of 3. Simplifying this even further, we have negative 4, x, we have y to the power of 8 in the numerator, and y to the power of 3 in the denominator. That's just going to give us y to the power of 5. Since we can't simplify even further, this is going to be our answer. This was pretty long and tedious, but the more you practice, the more you'll get the hang of it. Thanks all for watching. Please like this video. Please go ahead and subscribe. If you have any questions or concerns, please leave a comment in the comment section below. And we'll see you in the next video.